All right, so you're going to have to be able to fill out one of these charts for your test. You will have your periodic table with you. So everyone should have that out in front of them so they can go ahead and look at it. So what you're going to do is use your periodic table and then your knowledge of the atom to fill out the rest of these blank spaces. The first column is the element symbol, and that is always, always, always going to come from the periodic table. You're just going to look at your periodic table, figure out what the element symbol is. So is the atomic number. Always, always, always going to come from the periodic table. So what I'm going to do is look at my periodic table, find C, and figure out that on the top it says 6. That is the atomic number of carbon. So those first two things come from the periodic table. As does the third one, atomic mass. The difference is atomic number is the whole number at the top. Atomic mass is the number with decimals at the bottom. And for carbon, that is 12.01. The next number, the mass number, can be a little confusing between that and atomic mass. Remember, it's like grading. The mass number right here is like your individual score on a test. It's going to be a whole number. It's a total of all the points you earned. Atomic mass is the average. So atomic mass is going to be found on the periodic table, and it will have a decimal. Mass number is always going to equal the number of protons plus the number of neutrons, and it's going to be a whole number. So really, you're going to skip that and go fill out protons, neutrons, electrons first. Remember that protons is always equal to the atomic number. So if I look here and figure out the atomic number is 6, then I automatically know always, always, always the number of protons is 6. Always. Neutrons and electrons can be different than 6, but it must be indicated somewhere that it is different. It's called an isotope if it has a different number of neutrons. If you look here, there is nothing written anywhere here that indicates it's not 6. So unless otherwise stated, neutrons and electrons equal protons. So then I go back and figure out the mass number. So I'm just going to add 6 plus 6, and I get 12. 6 plus 6 is 12. I'm going to do one more. So I look on this next line. I really don't have anything. It appears that I don't have any information. But if I look here, I have protons and I have neutrons. So we're going to kind of work backwards. I know that the protons and the atomic number should always be the same. So if I know the protons are 15, the atomic number has to be 15. Once I figure out the atomic number, I can use my periodic table, look at the whole numbers on the top, and figure out that number 15 is phosphorus, and the symbol is P. You would use the periodic table to do that. You would then use the periodic table to figure out the atomic mass, which is 30.97. Now the mass number. I have protons, I have neutrons, so technically I can figure it out. Normally, if they're the same, you would just add them together. Even if they're not the same, you're going to add them together. But notice, there is a different number of neutrons here. These two numbers are not the same. So that tells you that this is an isotope, but you still get the mass number the same way. You add. So you do 15 plus 20 to get 35 as your mass number. And then since there's no indication it's anything different, electrons will also be 15. So the difference here with this one is right here. The problem gives you 20. It gives you an indication that something's different. But actually, your work is still the same. You're still going to add the protons and neutrons. It's just this time it's going to be a different number.